Let's start here, and it's the very question that many organizations are asking themselves. What does it mean when they don't control the physical machine? Does it increase the risk? As I've said many times now, I actually don't think this is a good question. It's very black and white. Is it more risky or less risky? Because conversely, you could ask this question. Is it possible that the cloud provider could manage the infrastructure better than what the organization themselves could? That goes back to one of the points I made in the very first module, when I showed you how huge those Google data centers are and how they're able to commoditize the way these resources are managed and do so in a very professional manner. So again, just saying, is it more or less secure? Is the risk increased or decreased? Is perhaps not the right question. But let's actually touch on that concern I raised in the last slide. What can possibly happen if you're sharing infrastructure with someone else? We looked at hypervisor breakouts earlier on. Let's look at another risk related to sharing underlying infrastructure. In 2015, we saw an attack emerge that became known as Rowhammer. And what we're talking about here is a very low-level attack that goes all the way down to the way dynamic random access memory, so memory we also know as DRAM, could possibly leak charges and, as Wikipedia says here, interact electrically between memory cells, possibly altering the contents of nearby memory rows that were not addressed in the original memory access. The bottom line is that Rowhammer can potentially change the state of memory outside the intended function of the process that's using it. As the article goes on to explain here, we actually saw that used in some privilege escalation exploits. Now think about this from the perspective of cloud, and in fact think back to when I talked about hypervisors. Rowhammer is an attack against the underlying physical infrastructure, not the logical infrastructure or anything else which is isolated by the hypervisor. This is precisely the sort of thing that organizations are worried about when they share infrastructure with other customers. Now, I've included this down here at the end of this module in other potential risks, simply because it illustrates the fear of sharing that underlying physical infrastructure. There weren't workable attacks that were used in cloud environments that allowed one customer to start modifying or accessing another customer's data. Certainly none that became publicly documented anyway. But that's part of the concern. We know that true potential of many of these exploits are kept silent and are used in malicious ways that we may never know about publicly. Whilst there is shared underlying physical infrastructure, this is the sort of concern that opponents of cloud computing will raise. Let's look at one more, and this one is a little bit more hypothetical. In 2016, there was a study done that showed how crypto keys on a machine could be obtained by another machine in another room. And that first machine was air-gapped as well. It was not connected to a network at all. Now, what the researchers from Tel Aviv University found is that they could measure the target's electromagnetic emanations, and that alone could potentially extract the crypto keys. This obviously required some pretty specialized hardware, as you can see in the image to the bottom left here, and it did also require pretty close proximity between that equipment and the target machine. It was just on the other side of the wall. But it was significant in that the machine was actually air-gapped, and it was a very simple passive observation of how the machine was behaving. Now, in fairness, relating this back to cloud computing, it's a very long bow to draw insofar as what these guys were able to do having any impact whatsoever on the way machines run day to day in the cloud. But look at the problem this way. What many organizations are concerned about is that when they no longer have physical control of the infrastructure, they become somewhat xenophobic. They're afraid of the unknown. Now, whether that be Rowhammer or specialized electromagnetic gear looking at the emanations from a machine, the feasibility of these attacks is almost a secondary consideration, because the concern is simply that it's not within their control. And often the belief is that if those machines sit within an organization's data center, attacks like this simply won't happen. But of course, there have been many attacks against physical infrastructure that exists within an organization's data center. And they might not be the ones we've just looked at here, but they've been much more classic styles of attack, often attacks from things like malicious insiders, or actors who've managed to socially engineer themselves onto an organization's premises. They're different attacks, and this again speaks to the whole premise of cloud security being different rather than better or worse. But one thing that does play into the favour of cloud security is that when we look at cases like the Xen hypervisor breakout, and that was a serious bug, it now becomes someone else's responsibility. And one of the positive things about cloud security is that when you use a provider the size of Amazon or Google or Microsoft, they have an almost unparalleled ability to identify, patch, and deploy defenses against these risks in record time. And that's a really good segue into talking about cloud computing security strengths. So let's go and wrap up this module, and then we'll go and look at the good security aspects of the cloud.